Hello, my name is Nicholas. This is for CSC 230 Internet of Things Lab 6.1 using a voltage and analog input to determine temperature. So on the screen right now, it took some images of how my breadboard works for the voltage divider to help get the raw data for the M5 Core 2 to take in and calculate all we need to do for this assignment. So the whole goal of this assignment is effectively using a thermistor to help determine the ambient temperature by using resistance and voltage to effectively to pull it off. So this is the video demonstration. So let me show you how this works. Show you the code. So right now, as it's hooked up, I think I'm getting a value. You should see 69.60 to 70 is where I'm roughly at with temperature. My ohms is 9,000 right now, and the ADC value is 3,000 is the ADC. So those are my ohms right now. So what I'm gonna do is I'm gonna quickly put this in my refrigerator over here for a bit. So while that is running, I can explain some of my other parts of the code and what's really going on, just to show you that it is working. Okay, left that in there for a little bit, but yeah, effectively, the how we were able to do this is we just get the inputs from the voltage divider, which is taking the raw resistance, turn it to ADC, analog to digital converter, which then allows it so we can take that raw resistance information, turn it from ADC, turn it into voltage, measured voltage from the AC value, the resistance value from the voltage divider from the thermistor, take that voltage, turn it into resistance, ohms, so we can figure out what's the resistance of the thermistor. Now that we have that, we can just take that the thermistor's resistance, or the ohms we just received, and turn it into temperature. Now, to do that, I use the Steinhardt equation, which is on the left side of the code over here. That is explaining it. This part right here is just setting up the temperature. The bottom float here is just simply taking whatever the resistance we got from Steinhardt, from turning it from Celsius now into Fahrenheit, so you can read it in Fahrenheit. The bottom display here is just displaying all the information, taking the ADC value, the voltage, the thermistor's resistance, the temperature we're getting, and all that. So that's all that part of the code is doing. Up here is helping to determine the thermistor's resistance. This one right here, by reading the defined constants from the I've defined up here, which are all like the configuration part. So like me dividing the reference resistors, the nominal resistance, the temperature I'm trying to reach, the beta coefficient, which are all values that are needed for the equation part of this assignment. So that is effectively how the code is structured. So let me go grab my M5 to show you that it can change temperatures and we be getting different results. Okay, so before it starts heating up again. Okay, there we go. We are reading what a resistance of 1300 and ADC value of 27 at 57, 56 degrees right now is where it's at. So we're able to yeah, it's be able to determine the temperature based off the voltage surrounding it. So that is my video demonstration. So other than that, thank you. Have a good one.